Hey guys, happy Monday. I'm sorry that you missed live class, but let me tell you what we talked about today. We are focusing on fossils. And so my question for the do now is, what if a paleontologist, which is an old time studier, this is like somebody who studies ancient things like fossils, found two fossils in this cliffside. Look at these layers here. Remember what we learned about how sedimentation works last week. And so paleontologists found two fossils in this cliff, one from layer A at the top and one from layer B. Which fossil is older, the one that's in layer A or the one that's in layer B, and why? Think about that. Put an answer on the slide. Let's keep it moving. So after our science of the day and our learning target, got a couple vocab words for you. During breakout rooms, we're going to watch a short little video about how fossils are formed. We're going to learn about this important law of superposition right here. And then independent work will be some games, and there is an exit ticket quiz. So pay attention and do well in the quiz, and you're going to have a good start to the quarter. This is Dr. Nazir Ibrahim. He is US based. He is not originally from the United States. He's a paleontologist and a comparative anatomist, which means he compares the anatomy, the body parts of different species over specifically by using fossils. He has degrees in geology, earth science, biology, and life science from a university in England, the University of Bristol, and he has a PhD in paleontology from the University College in Dublin, which is in Ireland. He travels all over North Africa looking for fossils of animals and even some of humans, and including cool dinosaur ones. And so he's most famous for unearthing something called the Spinosaurus. And so you can watch this TED talk about him talking about the amazing adventure he had when he went to find that. There's also a little bit of a is it a video here about his work, which is really cool. And you can watch more about if this is the kind of thing that's interesting to you. It's like a modern day what's the guy? Dun, 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 dun. Indiana Jones. Not necessarily looking for old religious symbols, but fossils. Pretty cool stuff. Today we are going to be learning about fossils, so that our learning target today is we will be able to describe how a fossil is formed, how it forms, and then also be able to analyze rock strata, that'd be rock layers, to determine which layers are older and newer. So there's kind of two things, like what are fossils, how are they formed, and then where we find them, what does that tell us about the different layers of rock? Obviously, this is amazing. I love this. I want to ride a T-Rex all the time. I think it looks cool. To the standard that we're working on today, it's a little bit different from last week, and even a little bit different for tomorrow. We're just going to kind of take one day to kind of knock this standard, where we are going to work to be able to construct an explanation based on evidence from rock strata. That's evidence from layers of rock for how the time scale of rocks. I'm trying to put this into words. Geologic timescales, like the timescale of the Earth, is used to organize Earth's history. It's been around for over 4.5 billion years, and we can learn a lot about it by looking at layers of rocks. And that's kind of what we're talking about today. Okay, quick Pear Deck question as we start thinking about fossils. Which of these is a fossil? This looks like here's maybe like a dinosaur looking thing. There's looks like maybe a spider caught in rock. This looks like a plant or something. Which of these is a fossil? It turns out they're all fossils. Trick question. You guys probably expected that. There's a lot of different things that count as a fossil. A fossil is any evidence in rock of an old plant or animal or other organisms. That means that footprints, look at these sweet footprints found, like somebody walked. This looks like, I don't know what this animal is, honestly. It's not a person, but a sloth or something was walking through kind of some wet sand. And then it got covered with ash from a volcano or something right away and preserved. And then people found it. They dug it up and they're like, oh my God, look at this. This is sweet. You can imprint. So this is like in, again, kind of wet sand or wet layer. A fern gets pushed into it, And over time, the fern decomposes, but this imprint stays. This is a petrified log. That means this is like a rock in the shape of a very, very old log. Going back a slide, this counts as a fossil. This is like if you've ever seen Jurassic Park, the whole premise is that like a mosquito gets stuck in amber. So this is like tree sap amber that gets that like wraps around and hardens over a an arachnid or an arthropod of some kind. That would be like arachnid, the spiders and insects and stuff, which is kind of cool. So there's a lot of different things that count as a fossil. It's any evidence in an old plant or of ancient organisms in rock. And check out this link when you have time later. If you're interested in fossils, if that's something that's like sweet for you, check it out. It's really cool. Thank you, Miss Beatty, for finding that for us. Okay, so 2 quick vocabulary words. We're going to talk about sediment today. Sediment are tiny little pieces of rock and minerals that were deposited, that were left there by wind or water. And they end up making these different lines, and we call it sedimentary rock, this types of rock. There's different types of rock. Today we're going to talk really just about one, and that is sedimentary rock. Versus a couple other rocks that form underground. Metamorphic rocks are rocks that are like pressed hard and under a lot of heat underground. Volcanic rocks are called igneous. I don't know why. Why don't we just call them volcanic? Volcanic rocks, guys. These are the rocks that like the lava comes up and it forms that way, or like magma under the air, under the layer, under the crust. They harden, and that forms this kind of rock. These rocks are actually formed on top of land. So today we're going to be looking at a video, this video about how fossils are formed, and you're going to try to answer these questions. Ways that animals can be preserved. How are most dinosaur fossils formed? Try to explain, this is a really short video, it's like 2 minutes. So try to explain the steps for how a dinosaur is formed, the natural mold specifically. And there's a true-false question at the bottom. Dinosaur fossils are made of real dinosaur bones. Is that true or false? I'll tell you right now that dinosaur fossils, when someone says, oh, that's a dinosaur bone, that thing is at least 65 million years old. That bone would have long ago decomposed and broken apart and went away. So when we talk about dinosaur bones, we're actually talking about rocks in the shape of dinosaur bones. So technically, I just want you guys to kind of understand what a fossil really is. It technically is not a dinosaur bone, but it is in the exact shape of a dinosaur bone. And so you'll watch this video to find why, but this is false. Fossils of something that old, at least, are not technically bone. They're made of rocks in the shape of bone. So we're looking at, so you definitely pause me and go back and do that. I'm going to keep going. We talked about layers of sediment forming in the video, and so we're going to kind of zoom in on those layers today to determine how old they are and which ones are the oldest ones. So new layers of sedimentary rock are formed because new layers of sediment are carried and piled on top of each other. That eventually you have so many layers that it pushes down hard and it's like really heavy under here, and that cements it all together at the bottom into a rock. That's exactly what you see happening in some place like the Grand Canyon. You see all these layers going up, all these layers in the rock. This was formed over millions of years with layers and layers of sediment and then being pushed down on top of each other. Think about this. Which part of a snowman do you put on last? The part of a snowman you put on last is the head. And that's because the most recent layer is at the top. This idea is called, so the bottom layer is the oldest layer. It went down first. Think about the snowman, the base of the snowman, you had to roll up first. If you think about your layers of clothes in your room, if you just pile all your clothes up, the clothes at the bottom are the ones you threw in first. And that means that at the top, Those are the youngest, the newest layers. Those are the ones that formed more recently. Just like the head of the snowman, you stuck on top, and it's more recent, it's newer. This is called the law of superposition. This is what it's called. The idea that the top fossils, the top rocks, are newest, and the bottom fossils, the bottom rocks, are oldest. That has a law, a name to it, and that is called the law of superposition. And it was a big deal when people figured it out, because now we can look at a whole a whole canyon and find fossils in different places and know which ones are older and which ones are younger. And it helps us understand how life changed over time, understand how the earth changed over time. And if we can date a specific fossil, we know, oh, this fish fossil was this many years, many millions of years ago. This is this many. We can actually start getting an idea of exactly how old these rocks are and exactly what was happening in the earth that time, tens of millions, hundreds, even millions of years ago sometimes, which is really cool. So, like this, the deeper we dig, the farther back in time we see. Most paleontologists don't like stand on a hill and dig straight down. That doesn't seem to be as useful. It helps to go to a place like cliffs and see a lot of different layers at once. Just throwing that out there. Okay, so during independent work today, you have a couple of cool games to play where you're practicing this idea of law of superposition, and you're gonna take this fossils exit ticket. That's it. If you want to practice these, please do. After you play the game, come and practice these ideas, which is how can you tell which is the oldest layer? Tell me here. Which of these organisms lived for the longest time, and how do you know? Answer that here. And then take your exit ticket. I will see you in class next lesson. Bye.